All right, so let's look at symmetry. So I think there's not a whole lot to do here. You might have to be a little bit good at some of your identities, because the main algebraic part of this section is a matter of simplifying an expression and realizing when it's actually equal to another expression. So let's take a look at that and we'll see what I mean here. So symmetry. So it's a sort of a graphical concept, but then how is that reflected in the algebra and how do you determine it? That's what we're looking into here. So that just so there's a couple of concepts that are basically the same, but it's a different language for saying kind of the same thing, whether you're talking about the graph or if you're talking about a property of a function. So sort of let's start with even. Even is a little bit easier here. So are there two m's in symmetric? I'm weirdly paranoid about my spelling here. Yeah, okay. About or around, I've seen it written either way. Well, so concept number one, one of our favorite examples of something like this is, well, here's the y-axis. So symmetric about the y-axis means that the y-axis you can think of it as being a mirror, and then whatever's on the right side is exactly the same as what you have on the left. So you have an x value. So you have an x over here, or if I want to plug in let's say a particular number in mind, like a. No matter what a is, a symmetric around the y-axis function means you plug in. Well, if I were a really good artist, then minus a would be right here underneath it, and the picture looks like this, and it's called and as mathematically we can say that f of a equals f of for all x, or maybe if our function has a restricted domain, maybe all x in the domain of f. That's all we're looking for here. So the picture here is what does it mean to be a mirror image? That means if you start at the origin and go to the right, if you're symmetric on the y-axis, you start at the y-axis, you go in one direction or you go in the other direction, you get exactly the same y values when you plug in those two different x's, and that's and the most common example of these is, this is where the name comes from. So x squared, or x to the fourth, even x to the 0 is a constant, is also an example. But this is actually, we'll look at this in some detail, and it actually ends up working if you have any even power of x. That's kind of where the name comes from. But it's a more general property. There are some functions in trigonometry that are even, and some of them we'll see, if you ever take trigonometry or I think pre-calculus, they revisit the trig functions as well. even and odd functions, the absolute value function, you might ask yourself, is that an even function or not? Something to think about. So yeah, we've got a picture. What does it look like? They're mirror images. That's how you tell by looking at a picture. Let's actually verify that this really is true. So proof or exercise, I ask you to verify, or ask you, is that an even function? Is it an odd function? Is it neither? Well, the definition is right here. This is a definition, this is an example, and then here's a proof that the example is actually true. Okay, well, we have f of x is equal to x squared. Well, what is f of minus x? Well, we plug in minus x in place of x, and well, if you're comfortable, you can maybe skip this intermediate step, but what we have is we have exactly two negatives, a double negative leaves no negatives left over because those even number negatives, they're all paired up with one of its opposites and they all cancel. So negative times negative is positive. If we had a third negative, it would be negative again, but it's not. Well, this is, well, x squared is exactly the original function, and then the left-hand side, what did we start with? And we just kept simplifying it. F is, I guess, I would say and. If I wanted to be, if this is our English class, I should say f is an even function. But there you go. So in this next one, I'll draw the picture second. Maybe you've seen this before, maybe you haven't. F is an odd function. I'm just going to write FCN as short for function. That's very common practice. If well, to make these look the same, well, it's the same two things. It's just I'm going to write them on the opposite side. It's saying the same thing, but I'd like to. Maybe I should have written f of minus x on the left because that's how you think about it. You think about, well, I evaluate f and I plug in minus x, and what do I end up with? Well, this is the definition of an odd function. F of x equals, here's another function, I'll call it g. I could have called this one h, doesn't matter too much. But anyways, those are two different examples of odd functions. And, well, that's what I claim here anyway. Well, what happens? Proofs. Well, f of minus x is equal to 3 times, well, it's, well, the whole point is you just keep track of how many negatives there are. And having the negative in front of the x is the same thing as having the negative in front of the entire expression, maybe which I could write like this, which is the negative of f of x. So I started with f of minus x and I got minus on the outside f of x using some algebra properties here. And the definition of the function f, well, yes, that's what happened. So that's what happens when you have an even function or odd function. Most functions are not like this. It's very special, but let's do it for g of x, so g of minus x is minus x cubed, and the more comfortable you get with this, maybe once you understand the pattern, how many negatives are there? There's an odd number of minuses. Well, the minus comes out in front, and then we have, so that's a times, that's a minus sign. The minus comes out front, we get an x cubed, and that's minus f of x. So I did that kind of in a lot of detail, as if you're seeing it for the first time. And it's good to sort of question these things at some point to really convince yourself that you really do know why it's true. And that's how you know. That's literally what x cubed is, or minus x cubed is literally this. And two of the minuses cancel, and because there's an odd number of them, there's exactly one left over after you pair up all the others. And that minus comes out front, and it looks like this, but you should at least write down maybe these two things, and then what is it we wanted to prove? That f of minus x is equal to the negative of f of x. So that's, sorry, this one is, this example I called it the function g, so that's what I meant. Okay, so and there's a name for this. So if the function is odd, well, it's not symmetric. You have to sort of reflect it twice. You take the negative of x, and then you also take the negative of y. But it's not just symmetric about one origin. If you flip it twice, it's this other thing we call symmetric about or around. I've seen it either way. Yeah, it's symmetric about the origin. Anyways, it turns out that flipping sideways and then flipping vertical is the same as doing a 180 degrees around the origin here. So so what do we have here? So we've got x, y. We've got, let's let y equals f of x, which is equal to, like that one over there, is x cubed. So we have 1, 2, and then we have 1, 2, 3, 4, 5, 6, 7, 8. 2 cubed is 8, 1 cubed is 1. Good, have to stretch downward a little bit more. 1, 2, 3, 4, 5, 6, 7, 8. So negative 8. If I want to just count by 1 instead of counting by tens or something, whatever. So here x is negative 1, negative 2. X is 1, positive 1, positive 2. There's the origin, and then drop straight down. This one you have to sort of stop and think about a little bit. It's always like, it's a little bit easier to get confused with this one and think that it's odd when it isn't, or vice versa. But it's like you go right and then left at the same time, and then you go up and then down at the same time. So they're both reflected, and the end result is like 100. Is as if you turn the entire graph 180 degrees, you get exactly the same thing again. So 180 degree rotation is the same thing as minus x and minus y, given every, you have a and a b, you have a minus, you have a, b over here, then you have the negative of a, and the negative b on the other side of the graph every single time, no matter what. All right, so maybe just a few examples. I just don't want you to think it's always one or the other. But and don't get too, just always go back to the definition whenever you're in doubt. Don't make any assumptions just from the name. There are some things that are easy to assume that are like incorrect. So what I'm talking about here is even and odd have a different meaning just for numbers. And this is everyone's favorite one to get messed up, I think. So yeah, 3 plus 5 is equal to 8. That's an odd number plus an odd number. It's an even number. The terminology just comes from the fact that the function x squared and x cubed have these properties, but that we just defined for functions, but it doesn't. But adding functions together is a totally different story. So this is a totally different meaning of even and odd. They're related to each other because of the x to the n functions. X squared, x cubed, x to the fourth. But it's this does not carry over to functions. So and there are some things that you can say about adding together to either even functions or odd functions, but it's even plus odd, you don't really know anything, so you got to watch out for that. Just don't make any assumptions about that. It's usually it's easier to just start with the definition and go from there. But like for example, so let's call this problem A. Let's just start with odd function plus odd function because I want to f of we just did these two individually, but let's see what happens. So we're answering this question here, so we're taking f of negative of x. So every place we see x, we plug in the negative of x. So we evaluate this function not at x, but at the negative of x. So negative x, and there's an odd exponent on negative number, so the negative survives. 2 of them cancel, and then 1 is left over, and it's x cubed, and we factor out the minus. Well, what does that do for us? Well, that thing inside the parentheses is f of x. So odd function plus odd function actually gives us an odd function. That's not something you have to memorize, and the problems where this happens are usually easy enough that just working through the algebra is easier. If you do want to memorize some properties like that, you can. That is something you can kind of use, but you have to say that you're using it, and it's better to just know your definition and do it from scratch. So that's the danger zone right there. Let's call it the next one. I don't know, h of x. Just change the letters just a little bit. X squared minus x cubed. So I have to be totally sure that it's one of these three things. So hopefully that's not too hard. Let's see what happens. And if it doesn't look like it's working, then Well, if this is true, you prove it like that. If this is true, you prove it like that. Well, with even, it was, well, we saw one of those earlier, but if it's neither, one counterexample is all it takes to counter. Wow, I didn't write enough letters. Okay, example. There we go. All right, phonics. All right, h of a minus x is, what do we get? Well, these two have nothing to do with each other. Two different things happen, and it looks like the double negative is just you just get plain old x squared again. This one you have minus. Well, you have to be a little bit careful because there's a minus just from the function h itself, and then there's a minus on the x that's there's a minus that gets cubed together with the x. So you multiply three negatives together, you still get a negative, but then there's a negative out on the outside from the function itself. So this is the minus that's attached to the x that gets cubed. So we still get a double negative. So what do we get? Well, that doesn't look like, it's not the original and it's not the negative of it either. It's like one of them got changed to a negative, but the other one got left alone. It doesn't look like anything. So let's just try. Usually it won't. Usually when in the first 2 or 3 tries, you'll probably get a counterexample. So it does. I do want question marks. Let's put it over the equal sign. So what did I just do? So the end result we got is, doesn't look like either one. It doesn't look like h of x, and it doesn't look like minus h of x either. It doesn't look like it's even or odd. But let's count. Let's see. Is there a counter example? Usually you won't have to try very. Usually it should only, if you're really unlucky, it might take 2 or 3 guesses to find something. But sometimes, pretty often, you get it on the first try. So let's just plug in 1. H of 1, is that question mark? Is that equal to h of minus 1? With either a plus or a minus. Well, there's 2 things to check. Maybe if I should break it into 2 separate things. I shouldn't try to do 2 things at the same time. Maybe that's a little too confusing. But what's h of 1? H of 1, here's our function h. 1 minus 1. 1 cubed, that's 0. H of minus 1 is minus 1 minus 1 cubed. We have to be a little bit careful. That's 1, 2, 3 negative. So negative 1 minus. That's a triple negative, so it's still negative 1. So negative 1. Yeah. Oh, this one I didn't. Sorry, I forgot to square that one. I thought something was weird here. So squared, sorry. So this is a positive 1. Went a little bit too fast there. Okay, so plus, is there the negative from the formula and then a negative that's inside of the x cubed term? Well, okay, so here's h of minus 1. It's not equal to plus or minus h of don't know why I wrote it on the right. But it's let me make room for the minus at least. H of minus 1, we already saw that that's equal to 2. And do we get this with plus or minus? We don't get either. So this one, we said not, H is not even. H is not H is not even and H is not odd. So H is neither. That's it for that one. And yeah, maybe just an example with like a graph. Let's see. All right, so it's looking at the book, and some of these are a little bit harder than the ones that are on the practice test. So, I think those are going to be fine. So anyway, yeah, so sure, so I'll just do one or just a couple of graphs. I don't want to think about it too hard. I just want to have a few examples of each really, really quickly. This is a real test of my art skills here, but it's like as you go to the right and you go to the left, one goes up by equal amounts as the other one goes down. And the only thing so I'm always going up and down, always going up and down at the same time. If a computer had done this, it was really, really, really perfect. There would be a scale on here, and you could actually go along the axis, and you could actually plug in different x and y values. I just wanted to do it kind of quickly, but if this is y is equal to q of x, and q is, well, what is that one called when it's, remember? Yeah, that one's called an odd function. So you plug in x, you get f of x, you plug in minus x, you get the negative of that. So it's, you mirror the x's, but as the x goes in opposite directions, you get the opposite y. So you're mirroring as you go along. Both are just consistently mirrored. Both you mirror the x's, you don't get the identical y, you get the opposite y as well. So it's kind of a weird picture, sometimes kind of hard to draw. This is try to draw that a little bit better. Should. Okay. All right, so what do we get here? Well, here we don't start at the origin. When odd function has to pass through the origin, that's kind of the first, because 0 is the negative of 0, so we'd better get the negative of, we can't be us and our negative at the same time. We have to, the only way that, so what's interesting about odd functions, maybe I should have said this sooner, but this, well, the definition of odd function, if it has to be true when x equals 0 in particular, then it must be, well, this is actually saying this. Well, you add f of 0 to both sides, you get twice f of 0 equals 0, so that's the fastest way to prove that a function is not odd. It only works for odd functions. Even functions, f of 0 could be anything. This is like a fancy little shortcut that's only for odd functions, and some functions, f of 0 could be 0, but then it still fails to be odd for other reasons. So it's just, if you check just one point, you only have one point of data, but there could still be other problems. But anyways, this one, as we go to the right, we go to A, we have f of A, or, you know, if I call it, sometimes like take specific numbers and call them A, I'll just call it X, I guess. And then I go negative of that, go the other way around. Well, if I could draw better, these would be exactly the same height. And let's just do one that's just neither, so I don't know. Even this is, here's the x-axis, here's the y-axis. Well, I plug in 1, I get 1, 2, 3. So let's just, like, I don't know, we let g of x is equal to x plus 2, nothing too fancy. What happens, let's try plugging this one in. Well, you take any x value and it's negative. F of 1 is equal to 3. So what happens? This is f of minus 1 is definitely not equal to f of 1, but it's also not equal to the negative of that. So we have 1. F of negative 1 is 1, but it's not equal to f of 1 because f of 1 is 3. Minus f of 1 is minus 3. Those are not equal to 1. That's it. So G is neither even nor odd. I mean, if the problem asks you even, odd, or neither, and you just say that G is neither, I have enough context to know what you're talking about. So if you want to be long-winded, you can remind me what we're talking about, but in this context, if the instructions are written on the page and you answered the question and you did the computation, this is so what happens, it doesn't look like it's going to be even, it doesn't look like it's going to be odd, but I need at least one counterexample to actually prove it. And well, here it fails to be even. It fails to be even, and it fails to be odd because in particular we plugged in a sample point 1, and if it fails even once, it's busted. So f of -1 is 1, f of 1 is 3, and you mirror the x's, you don't get the same y, and you don't get the negatives of each other either. You get two things that have nothing to do with each other. It's not here, and it's not the negative y value down here either. So it's nothing. So that's it. So I think that was like kind of like one of everything. That's sort of the idea. But yeah, so practice test number 2 and test number 2 online is going to have this, and then the homework that you just got, it has a couple of these, so that should get you going.